What if I told you the most powerful weapon capable of shutting down modern civilization isn't built by humans? It's 150 million kilometers away. Our sun looks calm from Earth, warm, stable, life-giving. But in reality, it's a violently boiling sphere of plasma, constantly twisting, snapping, and erupting with unimaginable energy. Sometimes the sun releases solar flares, intense bursts of radiation. Other times, it launches something far more dangerous, a coronal mass ejection. A CME can hurl billions of tons of charged plasma into space at speeds exceeding 3 million kilometers per hour. If that cloud of magnetized particles is aimed directly at Earth, we're in trouble. Because when it arrives, it doesn't hit our atmosphere first. It hits our magnetic field. Earth's magnetic field acts like a protective shield, deflecting most solar radiation into space. But when the blast is strong enough, the shield shakes. And when it shakes, electricity flows where it shouldn't. We've seen this before. In 1859, the most powerful solar storm in recorded history struck Earth. The Carrington Event, telegraph systems, the cutting-edge technology of that era, began sparking violently. Operators were shocked. Papers caught fire. Some telegraph lines even continued operating after being disconnected from their power supplies, powered only by geomagnetic currents from the storm. Auroras lit up skies as far south as the Caribbean. People woke up thinking cities were burning. And that was in a world with no power grids, no satellites, no internet. Now imagine that same storm today. Modern civilization runs on electricity. Long transmission lines act like giant antennas during geomagnetic storms. When solar particles disturb Earth's magnetic field, they induce powerful electric currents in those lines. Those currents overload transformers, the backbone of the power grid. And here's the problem. High voltage transformers are enormous. They can weigh up to 300 tons. They're custom built, and replacing one can take 6 to 12 months. In 1989, we got a warning. A strong solar storm struck Earth and collapsed the Hydro-Quebec power grid in Canada. 6 million people lost power. The blackout lasted 9 hours. The grid failed in just 90 seconds. And that storm was far weaker than the Carrington Event. Power isn't the only concern. Satellites are extremely vulnerable to solar radiation. GPS accuracy can degrade by tens of meters. Communication satellites can malfunction. Airlines sometimes reroute polar flights during solar storms to avoid radio blackouts and increased radiation exposure. Astronauts aboard the International Space Station must move into shielded areas during intense solar events. And then there's the internet. While fiber optic cables themselves aren't directly affected by magnetic storms, the repeaters that amplify signals across thousands of kilometers rely on electricity. If those fail, long-distance connectivity could collapse. According to a 2013 report by Lloyd's of London, a Carrington-level storm today could cause up to $2.6 trillion in damage in the United States alone. Recovery could take years. So how likely is this? The sun operates on an approximately 11-year solar cycle. During solar maximum, sunspots multiply. Solar flares become more frequent. CMEs increase. We are currently near solar maximum. Space agencies like NASA and NOAA constantly monitor solar activity. Satellites positioned between Earth and the Sun can detect incoming solar wind and provide about 15 to 60 minutes of warning before a geomagnetic storm strikes. That short window allows power grid operators to reduce load or temporarily shut down vulnerable systems. Since 1989, many grids have installed surge protection and improved grounding systems, but here's the uncomfortable truth. Scientists estimate a Carrington-level event occurs roughly once every 100 to 150 years. It's been more than 165 years since 1859. Statistically, we may be due. In July 2012, a massive CME exploded from the Sun. It crossed Earth's orbit. We missed it by just 9 days in orbital timing. Researchers later concluded that if it had hit Earth directly, it could have caused damage comparable to the Carrington event. So could a solar storm shut down the world? Not permanently. This wouldn't be an extinction-level event. It wouldn't wipe out humanity. The atmosphere protects us from deadly radiation. But technologically, it could be devastating. A severe worst-case scenario could leave millions without electricity for weeks, or even months. No refrigeration, limited fuel distribution, disrupted banking systems, supply chains strained, hospitals relying heavily on backup generators and fuel reserves. The economic shock would ripple globally. Governments now classify extreme space weather as a national security threat. The NOAA Space Weather Prediction Center issues real-time geomagnetic storm alerts. Satellites are increasingly radiation hardened. Infrastructure is more resilient than it was decades ago. But no system is invincible. The sun doesn't hate us. It doesn't plan attacks. It simply follows physics. Magnetic fields twist, energy builds. Eventually, it releases. Most of the time, that release gives us nothing more than stunning auroras dancing across the sky. But occasionally, it reminds us who's really in control. So could a solar storm shut down the world? Not forever, but long enough to test modern civilization in ways we've never experienced. Because the next great solar storm isn't a question of if, it's a question of when.